Hello and welcome to Diksha Karnataka YouTube channel. So today I am going to discuss the fourth part of the chapter Electrostatic Potential and Capacitance. This is the last part, and as per the norm that last class will always be the KCET PYQs. So today I am going to discuss 25 latest PYQs from the chapter Electrostatic Potential and Capacitance. Okay, this is one of the important chapters, so a lot of PYQs to solve, 25 PYQs, not less, right? So this is a huge amount of opportunity for all of you. And if you are watching this channel for the first time, or if you are just watching it without subscription, don't forget to subscribe, because we know many of our viewers, they come watch the videos but they do not subscribe to our channel. Why it is important for you? Because if you are not subscribed, you are going to lose out on all the information, all the latest update that is being happening in our channel. So do that and obviously all the chapters we are going to cover in our ACE series absolutely free of cost. So do not forget to subscribe and click on the like button, so that I also know that you have liked it. And this is a recorded session because obviously I am not here right now. By the time you are watching this video, I will be traveling, so this video is on a recorded mode. One important note though, if you have any doubts, any questions, feel free to ask me in the comment section below. As soon as I am free, I am able to reply to the comment, I will be replying back to your comment, right? So all the best. Let's start. So first question, obviously we will be also covering 2026 questions. Sorry, this is 2026 question. First few questions are 2026. Okay, so 2026 questions will also be covered in today's session. So let's start. A parallel plate capacitor has a uniform electric field E in the space between the plates. If the distance between the plates is D and area of each plate is A, then the energy stored in the capacitor is given by. So if you have followed my last lecture, there we have discussed that energy stored in a capacitor is given by half C V square. But if you see in the option, nowhere C is mentioned, nowhere V is mentioned. There are few other forms as well, but none of the forms are actually asked over here. Okay, you might feel that this looks familiar and I will tick it, but you also have to remember the energy density, that is energy stored per unit volume, is given by half epsilon naught E square. So energy density is half epsilon naught E square, but in this question they are asking you the energy stored, not the energy density. So do not make the mistake that thousands of students made while solving this question. They see that this looks familiar, I will tick it, but actually this is not the way to answer. Okay, this is easy but not that easy as well. Okay, so energy stored is different than energy density. What is energy stored? I told you energy stored is basically energy density into volume. Same as energy density is total energy divided by volume. Now what is the volume? If you know that the capacitor has an area A and distance between the plate is D, then the volume of the capacitor is basically A into D. That's it. So what is the total energy stored? Total energy stored is half epsilon naught E square into A into D. Very, very simple. Option C is correct answer, not option A. Okay, so normally energy stored formula is half CV square, energy density is half epsilon naught E square, but here they have slightly complicated the question, tried to confuse you. Not, I will not say this is a complicated question, because as you can see, only thing you need to know energy density and volume formula, and if you multiply that you will get the total energy. They try to confuse you because you tend to, if you are short of time, you tend to not read the question properly. You see this option looks familiar and tick it and go away. That is the to stop you from doing that, so that you make sure read the question. That's why they have given you this question like this, right? So easy question. Next, in the circuit shown in the figure, the potential difference across 4 microfarad capacitor is. So if you see in the circuit, there is a 4 microfarad capacitor as well as a 9 microfarad and 3 microfarad are in parallel combination. So first step, we have to simplify this circuit and calculate the equivalent capacitance. Now because this 4 microfarad connected in series, very interesting, because this is connected in series, whatever charge that we calculate for the equivalent capacitor, the same amount of charge will be passing through this 4 microfarad as well. If you have to do the same for this, then it would be little complicated, then it will be JEE mains level question, but because this one is connected in series, we simply need to calculate the equivalent capacitance and the charge passing through that. That will be same for 4 microfarad. So how to calculate the equivalent capacitance? 9 and 3 are in parallel. So 9 and 3 are in parallel. So parallel combination means the equivalent capacitance is basically simply adding them. 9 plus 3, that is 12 microfarad. So if you just add them, you will get the total parallel combination capacitance. Now this 4 and this 12 are now connected in series. So the total equivalent capacitance will be 4 into 12 by 4 plus 12. So if you remember the formula, C equivalent for series combination, C1 C2 by C1 plus C2. This is the formula for equivalent capacitance. So now 4 into 12 by 16, 4 plus 12 is 16, 4 4s are 16, 4 3s are 12, so this will be 3 microfarad. So the equivalent capacitance is 3 microfarad. The voltage source is 12 volt. So how much charge is passing through this? Charge equals to C into voltage. So that is 3 into 12. The same charge is also passing through the 4 microfarad because it is connected in series combination. So if the voltage across this is say V, the voltage across 4 microfarad say V, then the same charge is also passing through the 4 microfarad, that is 4 into V, right? Both should be equal. Now we are obviously not considering the units microfarad because both sides have microfarad, so microfarad will cancel. That's why we are not considering. So 4 3s are 12, so this is 9 volt. One point to remember that multiple capacitors are connected, so this value should be always less than this. The value of voltage across this should always be less than this. That's why the 9 volt is acceptable. Okay. So let's move on to the next question. An electric dipole of dipole moment P is placed. By the way, the previous question and this question both are from 2026. Sorry, I forgot to change the year. Okay, I was doing it manually when adding the questions, but I forgot to change the year. So both questions, in fact, the next question is also from 2026. So 4 questions came from this chapter. Okay, so now let's see this question. An electric dipole of dipole moment P is placed in the uniform electric field E. Then which of the following statements are correct? Statement number 1. So first of all, this is an uniform electric field. That is one. The electric field is E, the dipole moment is P. So torque on the dipole is P cross E. Torque on the dipole is P cross E. We have seen that. So this is correct statement. The potential energy of the dipole is minus P dot E. This is also correct. Potential energy is given by minus P dot E. That is also correct. Statement number 3. The net force on the dipole is non-zero. This is very important part. The net force acting on the dipole is 0 because the field is uniform. It is basically mixture of chapter 1 and chapter 2. So net force acting on a dipole in an uniform field is 0. Non-uniform field is not 0. Here the field is uniform, so force will be 0. So so correct statements are statement 1 and statement 2. This is incorrect statement. Okay, so the correct statements are statement 1 and 2 only. Statement 1 and statement 2 only. Next, a 200 joules of work is done in moving a charge 5 coulomb from a point A where the potential is minus 20 volt to another point B where potential is V volt. The value of V at B is. So work done is given. Okay, starting point's potential is given. okay, the charge is given, they ask you what is the final points potential. Now remember that work done in an electric field can be calculated as potential at the final point minus potential at the initial point into the charge. This is the formula for work done we have discussed, delta VQ, right? What is delta V? Delta V is the difference in voltage of the starting point and the ending point. So work done is given 200 joules. Final potential we do not know. Initial potential is given minus 20. Now here sign is important. For potential, sign is important. Charge is given 5 coulomb. So you have to find 5B, VB. So VB minus minus plus 20 equals to 200 by 5, which is actually 40. So VB equals to 40 minus 20 equals to 20 volt. So VB is 20 volt plus 20 volt. It is not 40 volts, but it is plus 20 volts. Next, before going into next, just wanted to remind you that our Pariksha Veera batch is going on in full swing, and if you want to register for it, the link of the Pariksha Veera batch is given in the description. Here we are teaching in live classes every day. And all the teachers are very engaging. You can engage with your teacher as much as you want. Okay, all your doubts will be cleared, and more details about the batch is at the end of this session. So do wait if you really want to know more about this batch, right? And if you want to purchase it right now, the link is given in the description section of this video. Now question number 5, a potential at a point A is minus 3 volt and that at another point B is 5 volt. What is the work done in carrying a charge of 5 millicoulomb from B to A? So here almost same question as 2026. In 2025, a potential at point A is minus 3 volt, okay, and that of another point B is plus 5 volt. Okay, here both potentials are given. Okay, what is the work done in carrying a charge from B to A? So work done is given by final potential. Here final point is A. So remember, final minus initial. So work done is always V final minus V initial into charge. Okay, so you have to be careful in your head which point is final. So 2A means A is last stop, B is the starting point. So final minus initial into charge. Okay, because in this question you might feel even though all the options are given negative, so final answer will be negative, but if the correct answer is given in negative and positive, I can bet that at least 20% students will fall for that and they will write the positive answer, not the negative answer. So that is one important point. So VB here is VA is here minus 3 volt. So minus 3 volt is the starting point. VB is 5 volt. So that will be minus 5. Charge given here is 5 millicoulomb. So milli means 10 to the power of minus 3. Okay, so it will be minus 8 into 5 into 10 to the power of minus 3, or it will be minus 40 into 10 to the power of minus 3. Now you have to check the answer. It will be given as, so if you take the 10 to the power of minus 3 means 40 divided by 1000. 10 to the power of minus 3 means in division 10 to the power of plus 3. 10 to the power of plus 3 means 1000. So 0 cancels and you get minus 0.04. So minus 0.04 joules is the answer for this question. Match column 1 with column 2 related to an electric dipole of dipole moment P that is placed in an uniform electric field. So this is also a super important concept. As you can see, back to back here questions came from this single concept, right? So angles are given, potential energy of the dipole is given. So we know that potential energy of a dipole is given by minus PE cos theta, right? This is the formula. So for angle 180 degree, cos theta is minus 1. So potential energy will be plus PE. So plus P is given over here. So for A, the option matching is 2. Okay. For 120 degree, 120 degree is equals to minus half. Minus half means minus minus plus half. So for 120 degree, the matching will be 3. So this will be 3. For 120 degree, it will be 3. For 90 degree, cos 90 is 0. So the 0 is correct match. So it will be 4. So 2, 3, 4 is the correct match. 2, 3, 4 is the correct answer. Option C is correct. Now let's move on to the next question. Which of the following statement is not true? So from this chapter also, true and not true kind of statement questions are also very common. Equipotential surfaces are the surface where the potential is constant. This is the definition of equipotential surface. Equipotential surfaces for an uniform electric field are parallel and equidistant from each other. This is also true. Electric field is always perpendicular to an equipotential surface. So if you see an equipotential surface, remember electric field is always perpendicular or normal to the equipotential surface. So this statement is also true. Work done to move a charge on an equipotential surface is not 0. So equipotential surface, work done to move a charge is 0 because obviously same potential difference is 0. Charge is there, but potential difference is 0. So work done is 0. So this is an incorrect statement. Option D is correct answer. Now this is 2024 question. Under electrostatic condition of a charged conductor, which among the following statement is true? So there are 4 statements, 1 is true. So as I mentioned, true false kind of questions are also common from this chapter. Every year one question came. 2026 there were 3 statements. They ask you which of the following statements are true. So basically there was 2 statements. Otherwise 25 and 26 also this type of questions came. So this is also very common from this chapter. But obviously topics are different for each year. The electric field on the surface of a charged conductor is sigma by 2 epsilon naught, where epsilon is the sigma is the surface charge density. Now for a non-conducting sheet, infinitely large non-conducting sheet, electric field is sigma by 2 epsilon. For a charged conductor, however, the electric field is sigma by epsilon naught only. For a charged conductor, the electric field is sigma by epsilon naught. So this statement is not correct. The electric potential inside a charged conductor is always 0. So electric potential inside a charged conductor is not 0, but it is constant. So this is also not true. Okay, electric field is 0, but electric potential is constant. Any excess charge resides on the surface of the conductor. This is the correct statement. If you give any charge to a conductor, charges always float to the surface. So this is a correct statement. Net electric field is tangential to the surface of the conductor. So net electric field is not tangential to the conductor. Net electric field is actually normal to the conductor. So this is also incorrect statement. So tangential statement is incorrect. So only option C is correct. Other options are incorrect. A uniform electric field vector E exists along the horizontal direction as shown. The electric potential at A is VA. A small point charge, small q, is slowly taken from A to B along the curved path as shown in the potential energy of the charge when it is at point B. Okay. So basically a small point charge is slowly taken from A to B along the curved path as shown in the potential energy of the charge. So here the electric field is constant E. Potential at point A is given VA. We have to find the potential at B. The distance between the point is X. Now they have taken a very weird path, but don't worry, work done due to electric field does not depend on path. It only depends between the direct distance between the points, potential difference and the distance. Okay. Now electric field is defined by electric field. The relationship between electric field and potential is basically VB minus VA by X, right? dV by dx. Now final potential minus initial potential by X is the electric field. So from here you can calculate E x equals to VB. There is a minus sign also. Sorry. There is a minus sign. So there is a minus sign. So if you adjust the minus sign itself in the equation, or you can keep it here like that also. So Ex equals to minus VB plus VA. Okay, Ex equals to minus VB plus VA, or VB equals to VA minus Ex. Okay, so correct answer. So work done to move the charge is basically Q into okay, so we have to calculate the energy, not work done, sorry. So energy of the charge particle is given by charge into potential of that point. Okay, energy is charge into potential of that point. So that will be Q into VA minus Ex. So that is correct answer is option D. Now remember, when you are moving in the direction of the electric field, electric potential decreasing. So if this potential is A, the final potential has to be less than that of A. So that means this is correct answer, not plus or minus. VA minus Ex is the correct answer, not Ex minus VA. Also plus is also not the correct answer. So this is one point that you have to remember if you are moving in the direction. I hope the arrows are clearly visible. So if you are moving in the direction of the electric field, the potential decreases. So A is at higher potential, B at lower potential. They did not ask you that exact work required. They ask you the final energy. Final energy is Q into the potential of that point. So that is the expression for final energy. Okay. Next, a parallel plate capacitor of capacitance C1 with dielectric slab between its plates is connected to a battery. It has a potential difference V1 across its plates. When the dielectric is removed, potential difference are C2 and V2 respectively. Then I think I have solved this question during our live lecture as well. If you remember that when you have a dielectric constant, dielectric slab between the capacitor plates, its capacitance is higher. If you remove the dielectric slab, the capacitance decreases, right? Because it is connected to the battery with the without being removed from the battery, the voltage should remain constant, but capacitance should decrease. So C2 must be less than that of C1, but V2 should be equals to that of V1. So capacitance decreases, voltage remains same. So that means correct answer is, I think there is a small typo here. So this, all of these will be 2. So correct answer is V1 equals to V2, C1 greater than C2. So C1 is greater than C2, V1 equals to V2. That means correct answer is option C. Okay. Next, the electric field and potential of an electric dipole along its axis vary with distance r respectively as. So electric field and potential of an electric dipole along its axis. So electric field varies as 1 by r cube, potential varies as 1 by r square. So this is again mixture of the two chapters. I hope you revise the previous lectures. So electric potential field is 1 by r cube, electric potential is 1 upon r square. Next, two tiny spheres carrying charges 1.8 microcoulomb and 2.8 microcoulomb are located at 40 centimeter apart. The potential at the midpoint of the line joining the two charges is. So here we have two tiny spheres. One of them is 1.8 microcoulomb. Okay, another one is 2.8 microcoulomb. Okay, the distance between them is 40 centimeter. They are asking you that the potential at the midpoint of the line joining the two charges. So both charges are positive. So potential should be equals to V1 plus V2. Potential is a scalar quantity, so can be added algebraically. So what is potential due to a point charge? It is K Q by R. So midpoint means this will be also 20. This distance will be 20. This distance will also be 20. So distances are also equal. So let's simplify it quickly. Do not use lot of calculations. We like to solve it as quickly as possible. So it will be so total potential will be K by R Q1 plus Q2. As simple as that. Okay. So what is K? K is 9 into 10 to the power of 9. The distance is 20 centimeter. That is 20 into 10 to the power of minus 2. Whenever you are solving questions, always convert centimeter into meters by multiplying 10 to the power of minus 2. Q1 plus Q2 is actually 1.8 into 2.8. So 1.8 plus 2.8 is 3.6, 4.6. 4.6 microcoulomb. 4.6 microcoulomb, that is 4.6 into 10 to the power of minus 6. Okay, now we have to simplify everything. So that means, so this can be cancelled, 10, 2.3. Okay, 2.3, 18, 27. So 20.7. So this will be 20.7 into 10 to the power of 3 plus 2 minus 1. So it will be 10 to the power of 4. Okay. So this is the potential at that point, 2.7 into 20.7 into 10 to the power of 4. But if you see, none of the answers are actually matching. So what to do? So 20.7 into 10 to the power of 4 can be approximated as 2.1 into 10 to the power of 5. So basically we have shifted one decimal, and 0.07 we are considering it to be 0.1. Okay. So this is now matching with our answer. This one, just calculate it, very easy, not a difficult, no rocket science here. Simplify it and you will be able to solve it. A parallel plate capacitor is charged by connecting a 2-volt battery across it. It is then disconnected from the battery and a glass slab is introduced between the plates. Which of the following pairs of quantities decrease? So we have a capacitor plate. It was initially charged to certain voltage. Okay, certain voltage it is charged. Now it is disconnected. Now what you have done, suppose the charge stored here is Q. Initially the capacitance was say C, C1. Now when you add a dielectric slab, first thing that will happen is that the capacitance will be increased. So C2 will be increased. As soon as you add a capacitor's dielectric slab, the capacitance increase, right? But being an isolated system, this capacitor, it is not connected to anything else. So being an isolated system, the charge should remain constant. The charge should remain constant, capacitance should increase. Okay. Now because charge is constant, capacitance is increasing, voltage should decrease because Q equals to CV. So if you are increasing the capacitance, charge remain constant, voltage has to decrease. That means in this particular case, voltage is decreasing. Now if voltage is decreasing, the energy stored in the capacitor is given by half Q into V. So again in that case, Q is constant, voltage is decreasing, energy stored should also decrease, right? So potential difference and energy stored both are decreasing. So just analyze the individual equation that capacitance increases, right? It is clear, right? When you add a dielectric slab, capacitance always increases, right? So capacitance increases. Now this is a isolated system. What is isolated system? Which is not in contact with anything, right? Even though you are inserting a dielectric slab, you are doing it in a insulated medium, it has a zero charge, right? Dielectric medium means it is a neutral object. So it is not adding any extra charge. So capacitance can be considered as an isolated system. So no charge is being added. So the total charge should remain constant. So total charge remain constant means Q is equal to CV, capacitance increasing. So this side is constant. So something has to decrease to balance it, right? So who will balance it? Capacitor increases, this is constant, so only voltage is left. So voltage has to decrease to balance the charge, right? So voltage is decreasing, charge is being balanced. Now from there, energy is half Q into V. So Q again is constant, voltage decreases, energy is decreasing, right? You can answer this question based on the method of elimination or based on the knowledge. Elimination means, as I mentioned, capacitance and charge, they are not decreasing. So any options with capacitance and charge are wrong. So if you see capacitance, charge, capacitance, here capacitance and charge both. So capacitance and charge are not decreasing. Anything other than capacitance and charge, they are decreasing. So only one option where neither capacitance nor charge is there, right? So either method of elimination or by method of deduction, both way this kind of question can be answered. If a slab of insulating material 4 into 10 to the power of minus 3 meter thick is introduced between the plates of a parallel plate capacitor, the separation between the plates has to be increased by 3.5 into 10 to the power of minus 3 meter to restore the capacity of the original value. The dielectric constant of the material will be. So basically we have, what is the question? We have a capacitor, the original capacitors of capacitance C. Now you inserted a dielectric medium between the plates. You inserted a dielectric medium between the plates. Now to balance it out, you have to increase the distance between the plates so that the overall capacitance remains same. Now we know that capacitance normally is given by C is equal to Ka epsilon naught by D, right? Ka epsilon naught by D. Now for this dielectric medium, when you are inserting the dielectric medium, its capacitance increases. Now if you increase the distance between the plates, this part is air, by the way, this part is air, okay? So basically it's a parallel combination of two capacitors such that the total capacitance remain constant, okay? So now there is a shortcut formula to calculate the dielectric constant directly. So what is the shortcut formula? The shortcut formula is the dielectric constant is given by the thickness of the dielectric medium, the thickness of the dielectric medium divided by thickness of the dielectric medium minus thickness of the slab by which it is increased, okay? So this is T and this is D. This is the direct formula that you can use to calculate the dielectric constant. There is nothing to be afraid of. Yes, you can use this formula. The derivation is basically you assume that the initial thickness was say T, you fill the entire thickness with dielectric medium and you increase this distance by D. What is the equivalent capacitance for this combination, which is tricky and long, but if you remember this formula, you can solve it in one line. So 4 into 10 to the power of minus 3 divided by 4 minus 3.5 into 10 to the power of minus 3 common for both of them. So this cancels and you get 4 by 0.5, that is 8. So dielectric constant of the medium is 8. Okay. Next question. 8 drops of mercury of equal radii combine to form a big drop. The capacitance of the bigger drop as compared to the smaller drop is. Now the problem is not difficult. Only thing you need to know that for a spherical capacitor, if the capacitor is spherical in nature, the capacitance is directly proportional to its radius. Capacitance is directly proportional to its radius. So if you can find the radius, you know what is the capacitance. There is a constant of proportionality of course involved, but if you can find the radius, then you can find the capacitance. So when 8 drops, small drops, say each of them are radius small r, okay, 1 2 3 4 5 6 7 8, okay, 1 2 3 4 5 6 7 8. So 8 drops of mercury, when they are coalescing to form a bigger drop of say radius r, okay. Now what will be the total radius? So you remember there is a, either you add all the volumes volume should remain constant. So total volume of all the 8 drops and total volume of this sphere is constant. Either you can do that way, or you remember very important thing that radius is basically number of spheres to the power 1/3 into radius of one of them. Okay, so here radius, how many drops were there? 8 drops. So instead of n you put 8. This is a formula, shortcut formula. Okay, so when a spherical object, smaller spherical objects are merging to make a bigger sphere, the radius of the bigger sphere is given by how many spheres are merging, that to the power 1/3. If it is instead of 8, if it was 27, you have to use 27, right? Generally they give a whole cube number so that you can take the cube root. So cube root of 8 is 2 into r. So even though 8 smaller spheres are merging to make a larger sphere, the radius is only getting double. Okay, so that means the capacitance will only be doubled compared to the smaller sphere. So it will be 2 times. So the capacitance of the bigger sphere is only 2 times compared to the smaller spheres, right? Interesting. Let's move on. Which of the statements is false in the case of the polar molecules? Again a statement, a false statement, false or correct statement. So these kind of questions are very common from this chapter. Centers of positive and negative. So we are talking about polar molecules, not crystals, not a whole substance, only single molecule of polar molecule. Center of positive and negative charges are separated in the absence of electric field. So this is the correct statement. If you read, we are trying to find false statement. Polar molecules, centers are already separated. Polar molecules, the centers are already separated. For this is polar. For non-polar, positive and negative are at the same position. This is non-polar. You need to check my theory classes regularly. So if you have any doubts regarding polar, non-polar, check my theory class. I think second part of this electrostatic potential and capacitance. There I have discussed polar molecules in detail. Okay. Next question, point B, centers of positive and negative charges are separated in the presence of external electric field. Now it is mentioned that they are separated in the presence of external electric field. It is not mentioned only separated. Okay, so in case of whether the electric field is present or not, the centers are always separated. So this is also a correct statement. If it is mentioned that only separates in the presence of electric field, then it would have been incorrect. But it is mentioned in absence of electric field they are separated, presence of electric field also they are separated, both are correct, right? Do not possess permanent dipole moment. So if you see that because their centers are already separated, they do have a permanent dipole moment from negative to positive. So this statement is incorrect. So this is a false statement. Okay, ionic molecule HCl is the example of polar molecule. So ionic molecule HCl is the example of polar molecule. Correct statement. HCl, H2O, they are all polar. They are all example of polar molecule. So this is the correct statement. So only do not possess permanent dipole moment is incorrect. Next question number 17. An electrician requires a capacitance of 6 microfarad in a circuit across a potential difference of 1.5 kilovolt. A large number of 2 microfarad capacitors which can withstand a potential difference of not more than 500 volt are available. The minimum number of capacitors required for the purpose is. So this question also I have solved during my theory class. So if you remember, so first case is we have to adjust or balance the voltage. So here we have those who have not watched my theory, I request them to watch my theory before watching this PYQ, because this is a very interesting concept. I explain in detail in the theory class how it is solved, right? It is done in the third part of the chapter. So let me clear it. Just a second. I don't know. Sorry. So basically, if you read the question, the requirement is 6 microfarad and 1.5 kilovolt. This is our requirement. What we have in stock? We have 2 microfarad and 500 volt. So both we need higher, okay, voltage as well as capacitance. Now you can increase the voltage rating by connecting them in series. So voltage rating can be increased only when capacitors are connected in series, because voltage will be equally divided. So 500 from this, 500 from this, 500 from this. So total voltage across it will be 500 plus 500 plus 500, that is 1500. That is 1.5 kilovolt. Okay, 1.5 kilovolt means 1500 volts. So to adjust the requirement of the voltage rating, we need to connect them in series. Okay, so that equally voltage is distributed equally. Now when you connect capacitors in series, the overall capacitance decreases. So overall capacitance decreases, and when equal capacitors are connected in series, the equivalent capacitance becomes C divided by number of capacitors. Here 1, 2, 3 are required. How do we find this number 3? For that, you take the output voltage divided by input voltage, whatever you get, that is the number that you will get. So 3 capacitors are required in series so that you get the required voltage rating. So C by 3, now equivalent capacitance of this combination is C by 3. Now how many such combination? Now we have to fix the voltage capacitance to 6 volt. So voltage issue is solved. So voltage regulator is there. But now we have to increase the capacitance. How can we increase the capacitance? Only way to increase the capacitance is connecting all of them in parallel. So we have to connect similar combinations in parallel, say n number of times. So n number of times if we connect them in parallel, what is the total capacitance? Total capacitance in this case will be total such combination into capacitance of each combination. Total such combination into capacitance of one single combination, so it will be NC by 3. Okay, so that is actually 6 microfarad. And if you see that each capacitance is given 2 microfarad, so N into 2 by 3 equals to 6. So N equals to 6 into 3 by 2, which is 9 microfarad. 9 capacitors, sorry. So 9 capacitors are required in parallel. 9 combination is required in parallel. Each combination has how many capacitors? Each combination has 3 capacitors. So total number of capacitors will be 3 into 9, that is 27. So in total you require 27. So first you adjust voltage, then you adjust capacitance, and finally you multiply both of them together to find the total number of capacitors, right? So 3 in one row and 9 such row. Okay, one row has 3 capacitors and we require 9 such rows. So total number of capacitors will be 3 into 9 is 27. Now next question. In figure, charge on the capacitor is plotted against potential difference across the capacitor. The capacitance and energy stored in the capacitors are respectively. So here if you see that this question also I have solved in the class. So only 120 microcoulomb and 10 volt corresponding voltage is given. So what is the energy stored? Energy stored is given by half Q into V. Because Q and V are given, we will use not half CV square, but we will use half Q into V directly. So half Q is 120, V is 10. So this will be 5. 5 12s are 60. So 600 microjoules. Why microjoules? Because the charge is given in microcoulomb. Okay, what about the capacitance? Capacitance is Q by V. Q is 120, V is 10, so that is 12 volt. This is 12 volt. Okay, now next is question number 19. The figure gives the electric potential V as a function of distance through 4 regions on x-axis. which of the following is true for the magnitude of electric field E in these regions. So you have to find the magnitude of electric field, not its sign. So if you see that from in the region A, the voltage is constant. Now, you know that electric field is given by magnitude wise dV by dx. So change in potential divided by change in distance. So when you are going in this direction, so this is the distance x, okay, this is the voltage. So here dV is 0. So dV is 0 means voltage is 0 here, okay. So at this particular point, the voltage is 0. Electric field is 0. Voltage is constant. So constant voltage gives you 0 electric field. What about this? So if you see that here, the in 1 meter range, the change in electric field is from 2 to 4. So electric field here will be 4 minus 2, that is 2. Distance dx is 1, dV is 2. So 2 by 1 is 2, right? Doubt? Okay, let me explain. So here, for this particular point from region B, the voltage is changing from 2 to 4. So change in voltage is 4 minus 2, final voltage minus initial. So we are ignoring the sign. Bigger minus smaller. So that is the change in voltage. Okay, what is the change in distance? Change in distance is this one, 2 minus 1. In fact, every regions are same except the second one, every regions are third one, every regions are same. So dx is 1. So what is the change in what is the electric field? So electric field will be 2 by 1, that is 2, right? So electric field here is 2. So electric field here is 2. Again, for this entire region, the voltage is constant. So voltage is constant means dV is 0. So dV is 0 means electric field is also 0. Now again in this 1 meter distance, dx is 1 again, for this also dx is 1. Voltage is now changing from 4 to 0. Voltage is dropping from 4 to 0. So what is the change in voltage? Change in voltage is 4 minus 0. Okay, so dV is 4, dx is 1. So this is for D. This one was for B. Okay, this is for D. Now what is the electric field? Electric field, so this was B, electric field B. So this is electric field D. This will be dV by dx, which is 4 by 1, that is 4. So obviously the electric field D is highest. D is highest, but for A and C are 0. So A and C are equal. So if you see A and C are equal and B is smaller than ED. So EB is smaller than ED. So EA equals to EC because both of them are 0. So this is EA. Let me change the color. This is EC, this is EA. So EA and EC both are 0, so they are equal, and EB is smaller than that of ED. That means correct answer is option D, right? Think this about this question, you will understand. If you are not getting it, understand, pause this, listen to this again, then it will be clear. Okay. Figure shows 3 points A, B and C in a region of uniform electric field E. The line AB is perpendicular and BC is parallel to the field line. So here if you see that AB is perpendicular, the line AB is perpendicular and BC is parallel, okay, to the field line. Then which of the following holds good? VA, VB and VC represent electric potential at points A, B and C respectively. So we have to find the electric potentials of A, so VA, VB and VC. Now if you see that arrows are pointing in this direction. Okay, so that means now this is perpendicular to the electric field, so this represents a equipotential surface. So AB is an equipotential surface. Okay. Why so? Because electric field lines are perpendicular to the line AB. We know that for equipotential surface, electric field lines are always perpendicular to equipotential surface. So basically it's a line, so equipotential line you can say, but basically the potentials of A and B are same. So potential of A and B are same. Now because both of them are on the left hand side, the C is on the direction of the electric field, these two should be greater than that of VC. So as you are moving in the direction of electric field, potential decreases. So VC must be smaller than VA and VB. V and VB both are equal. So VA equals to VB and both of them are greater than that of VC. So option D is correct answer. Logical thinking, logical explanation can lead to the answer of this question. Next, a dipole of dipole moment P and momentum of inertia I is placed in a uniform electric field E. If it is displaced slightly from its stable equilibrium position, the period of oscillation is. So even though this question is I think partly deleted, but it will be I by P, time period will be 2 pi I by P. This is the correct answer. This is a deleted question. Don't worry too much about it. I think I forgot to remove this question. The difference between equivalent capacitance of two identical capacitors connected in parallel to that in series is 6 microfarad. The value of capacitance of each capacitor is. So two capacitors, both of them are C. They are connected in series and in parallel. So in parallel combination, the equivalent capacitance is C plus C, which is 2C. In series combination, the equivalent capacitance is C by 2. As I mentioned, if the capacitances are same, okay, you just need to divide it by the number of capacitors to find the equivalent capacitance. So here two capacitors, C by 2. So the difference between them, so 2C minus C by 2 is 6. They are not different values, they are same values. So that is why it is a savior. So 4C minus C by 2 equals to 6, or 3C equals to 12, or C equals to 4. So the correct answer is 4 microfarad. Obviously microfarad is given, so answer will also be in microfarad, right? 4 microfarad. Two metal plates are separated by 2 centimeter. The potentials of the plates are minus 10 volt and plus 30 volt. The electric field between the plates is. So two plates are separated. Okay, one has say minus 10 volt, one has plus 30 volt. Okay, distance is 2 centimeter. The separation between them is 2 centimeter. What is the electric field between them? So electric field is again dV by dx. Okay. Now again there is a negative sign. I am ignoring it for the time being because only magnitude is important. So dV is basically highest voltage minus the lowest voltage. Change in voltage, difference in voltage. Okay, you can take minus 10 minus 30 also, or 30 minus minus 10 also. So both way, because we are taking positive values, we are using this, and the distance is 2 centimeter. Centimeter needs to be converted into meter. So 2 into 10 to the power of minus 2. So this will be 40 by 2 into 10 to the power of minus 2. So it will be 20, or 20 into 10 to the power of 2. So that will be 2000 Newton per coulomb or volt per meter. 2000 volt per meter. Here volt per meter is unit is given. So volt per meter, Newton per coulomb is given, Newton per coulomb. Both are units of electric field. Okay, volt per meter and newtons per coulomb. The equivalent capacitance between A and B. So direct question. So if you see, here is the circuit 50, 100, 150. Okay, equivalent capacitance between these 2 points. Okay, so basically if you draw it, if you take it like this and draw it like this, then it will be much easier for you to understand. Okay, so this is this point. This point is here. Okay, now we have 150 ohm over here and 200 ohm connected in the series. So this is the diagram. This is A, this is B. Okay. So the equivalent capacitance between A and B. So they have tried to give you an illusion of everything is in parallel, because they are not connected, everything is not parallel. So you have to rearrange it for your better understanding. So 100 and 100 are in series, 50 is in parallel, and then eventually you have another 50 is in series. So two equal capacitances connected in series. What is the equivalent capacitance? We will solve this using diagram only till the last stage. Okay. So here we have 50. Here we have 50. 100 and 100 connected in series. So equivalent capacitance 100 by 2, 50. Two equal capacitance connected in series. Their equivalent capacitance will be half. So that will be 50. Okay. Now this is 50. Now 50 and 50 connected in parallel. So parallel, they gets added. So 50 plus 50 is 100. So 50 and 100 now are connected in series. Now you have to use the formula that is 50 into 100 divided by 50 plus 100. This is the C equivalent, right? Now, so simplify 50 into 100 divided by 150, 0, 0 cancels, 10, 3 5s are 15, so it will be 100 by 3, okay. So 100 by 3 picofarad. You don't need to simplify it. The answer itself is given 100 by 3. So 100 by 3 picofarad is the equivalent capacitance. And let's move on to question number 25, last question of the day. A capacitor of capacitance C charged by an amount Q is connected in parallel with an uncharged capacitor of capacitance 2C. The final charges on the capacitors are. So here we have a capacitor of capacitance C charged by an amount Q is connected in parallel with another uncharged capacitor of capacitance 2C. The final charges of the capacitor. So first, one capacitor is charged, okay, with a charge Q. Now you have connected another capacitor 2C, okay. So now they are being asking what is the total charge, what is the charge distribution. So this was C, this is 2C. Now you have to remember that because the capacitor is after you connected uncharged capacitor, it is still is a isolated system. So total charge will be conserved. So if now the charge, say this one has a charge Q1, this one has a charge Q2, because the total charge is conserved. So Q1 plus Q2 should still be Q. So Q1 plus Q2 should still be Q. Okay. Now what? Q is equal to. Now if you can find the equivalent capacitance of this combination, what will be the equivalent capacitance of this combination? So the equivalent capacitance of this combination will be, so you can consider them to be connected in parallel. Obviously they are having the same voltage between them, okay, because no other voltage is there. So they are connected in parallel. So equivalent capacitance will be C plus 2C, that is 3C. Okay. Now just a second. No, we don't need to apply the condition of capacitance here. So only thing that we need to consider is that they are having the same voltage, okay, because no other voltage source is connected. One capacitor is charging the another. That means the voltage between these two capacitors should be same, and say that this common voltage is V. This is separate than the original voltage. So there is no relation between this V and that. That is the only trouble while solving this. So this V is a common voltage. So let's see how can we eliminate that. So we say that Q1 is equal to C into V. Okay, Q1 is equal to C into V, or V is equal to Q1 by C. Similarly, for the second capacitor, Q2 is equal to 2C into V, or V is equal to Q2 by 2C, right? So same thing we are applying. We are just eliminating the voltage V. So now we can compare, suppose this is 1, this is 2. If we compare both the voltages, we can write Q1 by C is equal to Q2 by 2C, CC cancels. So Q2 equals to 2Q1. Now we will put that in this equation. So Q1 plus 2Q1 equals to Q, or 3Q1 equals to Q, or Q1 equals to Q upon 3. I know it could be little more because you are solving a lot of questions since the start of the class. 25 questions may feel little boring at some times, but you have to increase the number slowly. So today I am solving 25 questions, tomorrow I will be solving 30, then 45, then 50, then 60. Then only will be able to pick up the pace. Some of you may be asking, sir, why only 25 questions? Have you watched till the end? Have you able to understand all the concepts? These 25 questions are very important and concept grabbing. Lot of different concepts that we have discussed in this session. Now here we are going to discuss briefly about our paid batch Pariksha Veera, where we are also teaching in a in-depth manner for your PUC as well as KCET, and also solving a lot of questions there as well. Not only here, we are doing there as well. So if you want to join our batch, the link of the batch is given in the description section. What you will get full PU2 coverage for all physics, chemistry, maths and biology, over 110 plus hours per subject, okay, which is our promise. And the entire PUC plus KCET syllabus will be covered by 6th of November. Okay, so entire second PUC plus KCET will be covered by 6th of November. You will get 20 plus tests, part and full length test for KCET 2027. Till your KCET exam, the batch validity is till 31st of May. If you are wondering, 31st of May the batch will be valid. So you can access everything, the lectures, the notes, the tests again and again, and that is valid till 31st of May. Okay. Teacher notes, assignments, unlimited DPP generator, everything will be provided, and it is delivered on the best online platform Wave of Vedantu app. Okay, so entire batch price is only 3499, and if you really want to you are interested in cracking KCET 2027, then definitely register yourself in the link given in the description section, so that you don't miss out on the classes that is going on. It is going on very fast. Every day it is going on. You already have missed some of the classes, but you can still recover. Only 1 week of classes maybe you have missed, so you can still recover that. But for that you have to join today. Don't miss out on that. Also, I will be coming back on our YouTube channel for absolutely free of cost for all of you, as we are doing in the past. We will be doing in future as well. So if you are not interested in buying the batch, you can continue learning from us in the YouTube as well. But one condition is that you have to like this video, and if you have not yet subscribed, don't forget to subscribe to our channel as well. Okay, I will be back. Till then,